So we measure these gravitational waves, we being humanity, not me, measure these gravitational waves coming from colliding black holes. So you have a black hole and a black hole, and they're orbiting each other. But as they're orbiting each other, they're giving off gravitational waves, which means they get closer and closer and closer together, and eventually they collide and give a big, bright burst of, or loud burst of gravitational waves. And the LIGO and Virgo and Kagra detectors are currently measuring quite a few such events of black hole binaries where the masses of the black holes are roughly a few to 10, 20, 30 times the mass of the sun. That's the sort of range that they're sensitive to. What this paper is looking at is now saying these black holes, if they've existed for long enough, will have gradually accreted to them dark matter. Because dark matter exists, massive stuff is massive, other massive stuff wants to fall into massive things. And therefore you would get this dark matter environment around the black holes. And the predicted signals of these colliding black holes are done in simulations where they're just isolated black holes orbiting and then colliding. What these guys are saying is that they're not isolated. They would have these big dark matter dresses around them, and that would change the nature of the detection. So I find this really fascinating because it covers a lot of fundamental physics. It would change in very subtle ways the predictions for gravitational wave detections. It would give us another independent source of evidence of dark matter. It would give us a sense of the history of these black holes.